In this video, I'm going to walk you through this Google Sheets template that I've created for carrying out keyword clustering, and this clustering or segmentation or classification, whichever way you put it, will be done on the basis of some metrics like CPC, CTR, and conversion rate. So this can be used in the context of portfolio bid strategy for Google Ads. I have been reading several posts on LinkedIn recently where people have been suggesting the use of TCPA portfolio strategy with the max CPC or the threshold CPC being set on the basis of CPC brackets or CPC ranges corresponding to the lowest CPA or the cost per acquisition. Now, the problem with this is that, you're talking about averages, right? And you're talking about ranges. So there's going to be variation within those. And it's possible to miss out important variations there, depending on, the intensity or the range that we are talking about and the number of actual terms or keywords that fall within that range. So this can be, by the way, both search term or keywords. And if the range is big enough, or there is a significant number, there's a significant number of keywords or search terms within a particular range, then it can become a problem because then you will not be able to pin down specifically on a particular CPA, which is going to be optimal for that for a specific set of terms. So that's why you have to, and this is particularly crucial because it's not just CPA, because you also have to look at conversion rate, you have to look at CTR. These metrics can also be important, and therefore they can ultimately have impact on the CPA. So you have to look at it from a multidimensional perspective. Basically, that's what I'm trying to come to. And that's why this clustering approach is pretty useful. This is an approach that I've obviously used using real data and real keywords, but I'm only looking at 3 metrics here. You can choose any intermediate metrics that you think are important and will ultimately matter in terms of your outcome metrics, like say ROAS or CPA or revenue, whatever. So this is the cluster. As you can see, what you're looking at right now is basically the output. We have the different clusters, cluster 0, cluster 1, and cluster 2. And each of these clusters obviously have a definition, right? So you can see cluster 0 here, for instance, corresponds to moderate CPC, moderate conversion rate. This one, cluster 1 here, corresponds to low CPC and moderate to low conversion rate. And cluster 2 corresponds to high CPC and high conversion rate. So if you just, so this is, by the way, the column for the clusters. And if you were to sort of filter all of these, you will be able to find out for, for each of the clusters, which are the keywords that are present. Okay, so you can find out for each of the clusters which are the keywords, and this is very useful because you can use this now in a portfolio bid strategy. You can obviously decide whether or not to put them together in a campaign or across different ad groups, and then you can apply the portfolio bid strategy, and you can set the different CPC thresholds based on the conversion rate that you have, and then decide, okay, so suppose this is cluster 1 you're talking about, that you're going to get a moderate conversion rate or maybe even a slightly lower conversion rate on the lower side. Then you know that, okay, this is whether or not you're going to bid aggressively. But when you're talking about higher conversion rates, and depending on the the importance of a conversion rate in your case, if that really means that you're generating much more revenue, getting far more conversions, you can do the basic math from it, and then you can decide, okay, then I can actually bid aggressively, there's no problem. Okay, so in most cases we'll see that the moderate one is the best one, and that will generally be the best one to bid upon. But you can see here that you will see that in this case, I think there are not too many moderate ones. Yeah, slightly lesser, but yeah, it depends on your data set entirely. So this is the idea, this is the output. Now let's actually look at how this sheet works, and I'll also explain what's really going on in the back end. There's obviously an app script. You only have to start with these data points, then an app script is going to do its work at the back end, and that's the output that you're going to get. It's going to give you the clusters, very simple, nothing fancy, but it does the work. It gives you the segmentation that you require from a multidimensional approach, instead of just looking at either just CPA or CPC range or like that. So this is how it works. So basically you have this button here, as you can see. I'll obviously have this Google Sheet linked in my description. And you can just click on this button, which is called K-means clustering. We'll come to that in a moment. That's basically the algorithm that is responsible for carrying out this multidimensional segmentation. So when I click on that, it basically is going to prompt you to give you the number of clusters that you want this data set to be divided into. I have provided 3, and now it's going to say that, okay, see, clustering has been completed, and you can see that the column E has the cluster labels for each of the keywords, and the column F has the cluster definitions of descriptions. So there you go. That's the same data output that you've got again here, and the further descriptions they were just manually put down by me, because you can see basically that this is the one which is the lower range of the CPC and the lower range of the conversion rate and so on and so forth. So this is what's the output. Now basically there's actually an app script that's doing all of this heavy lifting in the back end. As you can see, there's going to be a lot of functions. There is run k-means clustering and initialization of centroids and distance measurement and all of that. So let's actually understand what's k-means clustering. This is basically a machine learning algorithm, and to be honest, it's one of the easier ones. So if you are going to find this a little difficult, then I would suggest that you follow some of my other videos. I have talked about this in the past in my previous videos, but you cannot actually do without machine learning to a certain extent in today's world, in the context of marketing analytics or performance marketing. So this is basically what's clustering. So this is again k equal to 3. There are 3 clusters that have been created out of the data set, and you can see that it's as the name sounds. It is as the name suggests. There are 3 clusters. All the points are clustered together, and and as you can see, all of these points, when we say, and as we can see that they're clustered together, it also means that the distance between each of these points is much lesser than would be between the distance, than the distance between point here and in any other cluster, right? So that's basically what it does. This algorithm takes a point and then starts measuring the distances from each of the centroids of the cluster. So centroids are basically the center, some sort of a center of each of these clusters, and it measures the distance between that point and the centroid of each of the clusters, and then decides wherever there's a minimal distance, it just assigns that particular point to that particular cluster. So this is that iterative algorithm basically, and there's also a higher limit to which you can assign a number of clusters. You can obviously provide the cluster. As you can see, the user is prompted in this algorithm. This is of course a lot of Python code that does this, but this is something called an elbow method, which actually tells you what is the optimal number of clusters, because beyond that there's just not going to be enough improvement in basically reduction of errors. So most of the machine learning algorithms work in this way. There's there's this thing called sum of square errors. As you can see, this has to be reduced. Okay, so that's basically where the performance is measured, how good the algorithm is performing, so how well it is performing. So essentially it's this curve is telling us at what point this error reduction is no longer happening at any significant pace. Beyond that, any addition of number of clusters is not having any more significant effect. So as you can see, that threshold point here is around 3. 3 is a very common point, and in many cases we see that for clustering, k-means clustering, this is the optimal number of clusters, that is k equal to 3. So I can I'll leave behind a link. I'll probably give the link of StatQuest. It's an excellent YouTube channel. You can look at that for machine learning uh, or algorithms like this. So that's basically what is happening at the back end. So that's k-means clustering for you, and that's also this this sheet here. You can use more clusters, but like I said, there's a high possibility you can go ahead and check the elbow method if you want, and see the ideal number of the optimal number of clusters. But this is what I had to share, and I will share the the links, the references to k-means clustering, as well as the link to this sheet. If you have any questions, if you want any further clarifications, just do let me know in the comments. But for now, that will be all, and thanks for watching. See you in the next video.